Hello dear Fastmatic friends! Today fractions with letters. Algebraic fractions, where you have letters in the denominator. Follow me please. First of all, you have to identify if you have an addition, a subtraction, a multiplication, or a division. Here in this video, addition and subtraction. That is the same we made when we saw common fractions with numbers. So, first of all, before starting, we see that we have fractions with letters in the denominator that are adding or subtracting. So, always you're going to see if you can factorize those expressions. First of all, the number 1 is the number 1. You can't do anything. But here you have two terms separated by a negative sign. So, if you have two terms, you see the list of cases of factorization. Is something repeating in both terms? No, so you don't have monomial common factor. Is any parenthesis repeating? No, so you don't have polynomial common factor. Do you have three terms? No, so it is not a trinomial. Do you have 2 with square roots divided by a negative sign? Yes. So you have a difference of squares. How to do that? You take the square root of both in a parenthesis with a positive sign and in another parenthesis with a negative sign. After that, the number 3 is alone. You can't do anything. But here, we have two terms. Is anything repeating in both terms? Yes, the b. So we take the b with the smallest exponent. We open a parenthesis and we make divisions. The first term divided by the common factor and the second term divided by the common factor. B squared divided by b is b. Negative divided by positive, negative. b divided by b is 1. Because remember that the same thing divided by the same thing is always 1. After that, the number 3 is alone. We can do anything. And b plus 1, we have the 1 exponent here, the 1 exponent here. We can't do anything. And now, we have a very, very important decision to make. We need to calculate the least common multiple. So, we are going to write all the letters, all the expressions that are different, but if one expression is repeating, we are going to choose the expression with the biggest exponent, okay? And if you have something repeating with the same exponent, you leave it only once. So, what is the least common factor of that? b plus 1 is repeating here, so I'm just writing once b plus 1. After that, b minus 1 is repeating here, so only once b minus 1. Finally, b. Pay attention because one number plus 1 is different of another, the same number minus 1. And it is different of that number. That's why I write the 3, because they are different. And now remember fractions. When we added fractions with numbers, we divided first. After that, we multiply. And finally, we put that here. So, b plus 1 times b minus 1 times b divided by b plus 1 times b minus 1. If you can't do that in your mind, you write it b plus 1 times b minus 1 times b divided by b plus 1 times b minus 1. And because all of them are in multiplication, we can eliminate b plus 1 with b plus 1, b minus 1 with b minus 1. And the answer is b. So this divided by this, b times 1, b. After that, plus. All those expressions, all those factors divided by b times b minus 1, we can write it b plus 1 times b minus 1 times b divided by b times b minus 1. And we eliminate the same factors, and the answer is b plus 1. Times 3 is 3 times b plus 1. Finally, I write the negative sign, and this divided by this. In your mind, you can do that. The same are eliminated, and we have b minus 1 times b times minus 3 is b minus 1 times b. Finally, we simplify the numerator. We are going to erase those temporary procedures. Now we have b plus 3 times b plus 3b plus 3 times plus 1 plus 3. Now negative 3 with b times this binomial, we can do that. Negative 3b times b, negative 3b squared. And negative 3b times negative 1 plus 3b. b plus 1 times b minus 1 times b. Finally, we are finishing this exercise. We're going to write ordering with the highest exponent at the beginning. Negative 3b squared plus b plus 3b plus 3b plus 7b plus 3 divided by b plus 1 times b minus 1 times b. You could simplify those expressions multiplying, but I think it is good like that. Thank you very much, dear friends. See you next time.